2.8, curve fitting with quadratic models. Back in Algebra 1, you looked at comparing things with first differences. If you have a data set, first thing you need to worry about is that all the x values are equally spaced. Then the y values. First you look at the first differences. The differences there, I go from 9 to 4, it's -5. 4 to 1, -3. 1 to 0, -1. From 0 to 1, it goes up 1. 1 to 4 goes up 3. And the last one, 4 to 9, goes up 5. When we look at the differences of those, you notice that every single one of them goes up 2. Whenever you have second differences that are constant, it is proving that you have a quadratic function. It does not tell you what the function is, just says that you have one. All right, for the table, first thing you need to look at, if we're trying to determine whether the data set could represent a function, we look at the x values. Are all the x values equally spaced? 2, 2, 2, I'm good. Now we look at our first differences. What's the difference between a -1 and a +1? 2. The difference between a 1 and a 7, 6. Between a 7 and a 17. And the last one there, between a 17 and a 31, 14. Those are our first differences. Now we look at our second differences. Between a 2 and a 6, it's 4. 6 and a 6 and a 10 is 4, and a 10 and a 14. Because all of the second differences are a constant 4, it could represent, or it does represent, a quadratic function. Does not tell us what the function is, just says that it could represent. Our second example, looking across at the x values, what do they go by each time? 1. Now don't just look and see 3, 4, and then just assume they all go in order. Double check that all of them go by 1. On the bottom, what are our first differences? 10, 14, 18, 22. So once you take the first differences, we look again, what are they all going by? They're all going by 4. Just happens to be a 4 again. The answer again, yes. Do you understand how to determine whether a set of functions is a quadratic function? That's all you're doing. Really, in Algebra 1, you looked at the first differences. That told you if it was linear. Second differences will tell you quadratic, and so on. Now also, from Algebra 1, you made a linear model. Now we're going to make a quadratic model. All we're doing is creating a function that represents a data set. And we're going to use the graphing calculator to give us a quadratic regression. I'm not going to sit here and try to show you how to do it by hand. It's much quicker to just do it with a calculator. We're going to write a quadratic function that fits the points 1, -5, 3, 5, and 4, 16. So the first thing we're going to do in our calculator, anyone remember how to put these points into the calculator? Press stat, which is next to the left arrow. Press stat, left arrow, you see the stat button right there. You want edit. Now you have L1, L2, L3. The common place to put the numbers are in L1 and L2. That's the default for the calculator. If you put it in anything else besides L1 and L2, you have to inform the calculator of your change. So to type the numbers, 1, 3, 4. What did I do? I made a mistake, right? You have to know how to go back and fix a mistake. It's going to happen. If I press the delete button, what happened? and actually deleted it. Now you could rearrange all your numbers so you can just tack on the one you missed at the end. But I can go second, insert, it throws the number back in there. All right. I could have also just went, hit clear, and writes a new number. Or you just go back up and type the new number. You don't have to hit clear. Little things you need to know how to do. To get over to L2, press to the right. -5, 5, and 16. They should be lined up. If your numbers aren't even, you did something wrong. Most of the mistakes made on these problems are mistyping in a number, forgetting a negative. Now the next thing I'm going to hit, I'm going to hit Stat again. But now I'm going to go over to the Calculate menu. So press over where it says Calc. We're going to do the quadratic regression. Now if you selected any of these, it'll give you an answer, but it's not the correct answer. So 5, quadratic regression. Now if you have a TI-83, the black calculator, yours is just going to show up on a screen, quad reg, and that's it. Because what it's assuming now is you're doing the standard everything. If you want something to change, or if you want an L3 or L4, you have to manually type it. The L4, it's a little bit neater, where I can just go, if you change them, and say you put your Y's in L4. Second 4 would change it to L4. But for the most part, we want everything in L1 and L2. We don't need to change the frequency list. We don't need to change the store residual. Just go down to calculate. You can just hit enter, 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 enter. If you have an 83 or an 84, just press enter, and now it tells you this answer. Now it says A, B, C. Now if you look up top, it's telling you the correct form. So I have the function is 2x squared minus 3x minus 4. And that's your answer. That's all you do for your answer. Now I'm going to show you or remind you how to put these in the calculator to get graph. If I want to graph these points, I can press y equals. Now, we stored them in L1 and L2. We didn't do anything different. We didn't give them fancy names, didn't put them 1s and 3s. All you need to do is go up, turn on plot 1. So by turning it on, you just press enter. That turns it on. Now we want to graph. So I hit zoom. And since we're talking about statistics, we're going to go zoom stat, zoom 9. What this is doing here, you're only going to see on the screen the points that you selected. There's a line that goes through here, and that's this equation. If I go into y equals, some of you will just type 2x squared minus 3x minus 4. That does work. There is another way. And one of those enters you hit when you're doing the quad reg, one of them was saying where to store this information at. If you hit y equals, then press the vars button. That's the variables. It's right underneath the arrow, down arrow. When you press vars, we want statistic variables. 5. We're looking for an equation. So go over to EQ. Number 1, it'll look familiar because that was one of the things you hit enter on going through the screen. When I hit enter, it throws stuff into Y1. And if you look at it, you have 99994. What's negative 3.9999999 round to? Negative 4. What the calculator is doing is putting everything that was in the calculator. and not the rounding. So it's a more accurate answer. Now if I hit graph, there's those points, but now the line that goes through it. You can do this to check to see if you have the right equation. If you plot these points and you have this line here and if it's way up here, you know something's wrong. So you need to go back and look. Another thing I can use these for, sometimes you're asked to find what's the function at 2, what's the function at 10, what's the function at 25. I could sit here and go, this is the old way, take 2, store it into x, and then do the 2x squared minus 3x minus 4. My answer is negative 2. Then I'd have to go through and do it for the 10 and do it again for the 25. But since I already have the equation typed into the y equals, I can go second graph and go to the table. At 2, it's negative 2. At 10, it's 166. 25, it's 1,171. If you have to do multiple what's this, it's easier to just look at the table. So what I would like you to try right now, I have the point 0, negative 3, 1, 0, and 2, 1. Find the equation that passes through those points. All right, to put the new set of numbers, stat, enter. Now, to get rid of the numbers that are in there, some people will sit there and go and delete each individual number. Works if you only have a few, but if you have a ton of numbers, it takes forever. One thing I don't want you to do is to go up top here and press delete. What happens if I press delete? L1 is now gone. Now you can go with the flow and just put things in L2 and L3. But now you have to tell the calculator every time your x's are in L2, your y's are in L3. If that happens, which I'm sure it'll happen sometime or another, go back to stat and press 5. When you hit enter, it just says done. When you go back into your list, L1's back there. What you can do, though, is go up to the top and press clear, and then press enter. It clears it out. Type in the numbers. How do I get the equation? Stat, calc, 5. And then just keep hitting enter. Your answer is negative x squared plus 4x minus 3. And that's it. Questions on these? Yeah, if it's just a negative 1, I don't need to put 1x. We just write the x. It was negative, so that's why I put the negative out front. That first problem, I did all that extra stuff just to show you what you can do. But if it's just asking for the function, that's your function, that's your answer. Here's an application of this. The table shows the cost of a circular wading pool. The price is based off the pool's diameter. We're going to find the quadratic model for the cost of the pool, and then we're going to use that model to estimate the cost of a pool with a diameter of 8 feet. So if a pool has a 4-foot diameter, it costs $19.95. 5 is $20.25. 6 is $25. 7, $34.95. We want to find out what it would be at 8. First thing you need to do, put this in L1, this in L2, and find the equation. All right, putting the numbers in, I hit stat, enter. So I typed in all the numbers. Stat, calc, 5, enters. So I have f of x equals 2.413x squared minus 21.563x plus 67.638. Either round to 3 decimals or write the entire decimal out. Now, that's the model. To find out what it's going to be at 8, I could store 8 into x, and then type everything out. For me, it's a lot quicker. Go into y equals, clear it out, bars, 5, EQ, enter. It throws it in there. Right here, plus. Second graph, we want 8. If you want a pool that is 8 feet in diameter, it would cost you $49.54. Now, if you use this and estimate it, your answer is going to be off by a little bit of change. Why did I only use 2 on this one? 2 decimal places. We're talking about what? Money, and money can only have 2 decimal places. So that's why I rounded down one of the 2 decimal places. All right, this table shows the run times of a 16 millimeter film. Given the diameter of the film on a reel, we're going to find the quadratic model for the reel length given the diameter of the film. Then we need to find out what would be the reel length for an 8-inch diameter film. So if the film is only 5 inches of a diameter, when you unrolled that film, it's about 200 feet of film, which is equivalent to about 5.55 minutes of playtime. If we had roughly, or it's 13.75 inch diameter roll of film, if we unrolled it, it'd be 1,600 feet of film, which would give you approximately 44.25 minutes of playtime. So we're not even looking at the time. That's just so you have an idea of how much it gives you. In L1, put the diameter. L2, put the length. Get the equation, and then find out what your answer is for an 8-inch reel. Go stat, edit. See, I accidentally have an extra number in here, so if I delete it, it now fixes my problem. Stat, calc, 5, enter. There's your equation. I'm going to go into my y equals, bars, 5, EQ, enter. Second graph, my 8 is 611.41. If we go back, I didn't double check my numbers. This one right here should have been 1,600. So I just go through and press the buttons again. Clear it out. Put the correct one in. Second trace, or second graph. At 8, it's 446.85.